Click the bell icon to get latest videos from Ekeeda.
So, hello friends. In previous video, we have studied a first numerical based on a numerator degree is greater than a denominator. As I told you, if the numerator degree is greater than denominator, then we are not able to find out the inverse Laplace transform of any function. You can find out by doing or by performing a division method. So, we have solved one numerical based on that. Now we will solve a next varieties of numerical on that same basis. So we'll solve a current numerical or the next numerical problem number 2. Now the problem number 2. The question is find the inverse Laplace transform of function whereas x of s is s square plus 6s plus 7 and in denominator we have s square plus 3s plus 2. Now look at here. The degree in the numerator and degree in denominator is same. It is also not accepted. The condition is before finding inverse Laplace transform, the degree of denominator should be always greater than or must be always greater than numerator. But if it is not, then perform the division method. Now, how many times we have to perform a division? Only single times, because here the degrees are same. If the degree is greater than 1, then we have to divide this numerator twice. If here, look at here, and the last numerical the degree was 3 and in denominator degree was 2. So basically in previous numerical degree was greater than 1, that's why we perform division twice, or we performed division for next 2 steps. If here the degrees are same, then we'll perform a division only once. Now what I said, I'll show you. My question is x of s is equals to s square plus 6s plus 7 and s square plus 3s plus 2 in a denominator. What I said, if the degree in the denominator is greater, then we can move on to inverse Laplace transform, but if not, then we have to perform a division method, or we have to take help of division method. What do you mean by division? Simply divide this numerator by the given denominator. S square plus 3s plus 2, which is in denominator, and in numerator we have s square plus 6s plus 7. Now what is the next step? If we want to divide s square, and if here we have s square in the denominator, the first term and this numerator first term is much more important. Here the first term of in denominator is s square, and here the first term in numerator is s square, which means if we multiplied s square by 1, then you can get the s square value. So simply multiply this whole equation by 1. After multiplying 1 with this one, what you will get? S square plus 3s plus 2. What is the next step? Here the sign of all the terms are positive, so we'll replace it by opposite sign. So s square sign is negative, 3s is also negative, and 2 is also negative. This s square will get cancelled. 6s minus 3s become 3s, and 7 minus 2 becomes 5. So my x of s becomes, how to write the x of s equation? First of all, we will always write the quotient value. Here my quotient value is 1 and plus what is remaining? The remainder and the dividend. So first of all, we'll write remainder in the numerator part, that is 3s plus 5 in the numerator, and this denominator will be written as it is, s square plus 3s plus 2. And from next onwards, we can find out the inverse Laplace transform by performing the partial fraction on second part, because here now you have achieved the degree of denominator is now greater than numerator, and let's say this is my equation number 1. But before moving to equation number 1, I am going to separate this part, and I will consider this is my x1 of s. Let's say my x1 of s is x1 of s is 3s plus 5. In denominator we have s square plus 3s plus 2, and I will find out the partial fraction of this first. Now what is important? Factors. The last term is always product of two digits, whereas mid term is always addition of similar two digits. If we multiply 2 by 1, then answer is always 2. And if we add both the numbers, that is 2 plus 1, answer is always a 3, which means my factors are s plus 2 and s plus 1. And in numerator we have 3s plus 5. Now what is our next step? If we have a two simple poles, then we will use two separate variables. Let's say a and b. In denominator we have s plus 2 and in denominator we have s plus 1, and this is my equation number 3. What is the next step? Just multiply this denominator, left hand side denominator on the right hand side. What you will get? If you multiply this denominator on the right hand side, what will you get? S plus 2 will get cancel. A is multiplied will be multiplied with s plus 1, and similarly over here also s plus 1 will get cancel. B will be multiplied with s plus 2, and now simply substitute s values to get the different variable values, that is a and b. So first of all, I'll put s equals to -1 in this equation. So what you will get? This s is replaced by -1, so 3 into -1 is -3. 5 minus 3 becomes 2. So on left hand side we have only 2, but on the right hand side what we will get? This s is replaced by -1, which means -1 plus 1 becomes 0. So whole a term becomes 0. But look at here, over here in b, this s is replaced by -1, so 2 minus 1 becomes 1. So b into 1 is nothing but b, and this is the result of b. Similarly, we'll put s equal to -2 in above equation. What you will get? If I substitute -2, then this s is replaced by -2. -2 into 3 is -6, but -6 plus 5 becomes -1, and it is available on left hand side. Look at here. If I replace this s by -2, then -2 plus 2 becomes 0, so whole product becomes 0, so b will not be there. And here this s is replaced by -2, so -2 plus 1 becomes -1, and it is multiplied with a, so this answer is also -a. Now if we multiply or if we remove the minus sign, then what you will get? The a value is also 1. What is our next step? Substitute a and b value in my equation number 3. So my x1 of s become this is our x1 of s, and substitute this x1 of s value in equation number 2. Now after substituting x1 of s value in equation number 1, what I have got? X1 of x of s becomes 1 plus 1 upon s plus 2 and 2 upon s plus 1. Now simply apply inverse Laplace transform on this above equation. What you will get? Inverse Laplace transform of x of s is nothing but x of t. Now we know that inverse Laplace transform of 1 is always a del of t, which is impulse function or delta function. Next, 1 upon s plus 2. Here we have s plus 2, means what? We will take the help of frequency shifting property, and according to frequency shifting property, multiply this t, which is in power of e, by the opposite sign value of plus 2, and it is -2. So -2 into t is -2t. What else is remaining? This plus 2 will be removed, 1 by s is there, and 1 by s is nothing but unit step function, plus again I'll take this constant outside, which is a 2, and now here we have s plus 1. Again we will use the frequency shifting property, so e is multiplied by the e to the power t. This t is multiplied by the opposite sign value of 1, that is -1. -1 into t is -t, and after that what is remaining? 1 by s, and inverse Laplace of 1 by s is nothing but unit step. If you want, then you can add one more step over here. You can take this u of t common. What is remaining? E to the power -2t, which is this, plus twice into e to the power -t, and this is our answer. So you can stop here also, all is here also, you will get the full marks, don't worry. So This is all about the question number 2 or problem number 2. Now we will solve a next numerical next video, but thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.